Hello everyone. Welcome to the lecture number 3 on multiple integral. In this lecture, we will going to discuss how to find the integrals over the arbitrary region. We will discuss the properties of double integral and the applications of double integrals. The learning objective of this video is, after watching this video, the student will be able to find the area using double integral. Now we discuss how to find the integral over arbitrary region. Suppose A is the bounded plane region as shown in the figure. Let fxy be defined on this region A. We draw a rectangle R containing this arbitrary region A. Now we define a new function on the region R as f bar of xy. F bar of xy equal to f of xy if xy belongs to the region A and its value is 0 otherwise. That means if the point is outside the region A, then value of the function f bar is 0. So double integral over the region A for the function f of xy will be now equal to the integral over the region R f bar of xy. We discuss the properties of double integral. Linearity property. If there is addition of two functions f of xy and g of xy, then the double integral of this addition of two functions can be written as addition of two integrals, integral over f of xy plus integral over g of xy. And if the function is multiplied by some constant c, then this c can be written outside the integral. Comparison. If f of xy is greater than or equal to g of xy for all the points in the region R, then we can write integral f of xy is greater than or equal to integral over the region of A, g of xy. Additivity. If A1 and A2 are non-overlapping regions, then the integral over the complete region for the function f of xy can be written as addition of two integrals, integral over the region A1 plus integral over the region A2. We now discuss the applications of multiple integrals. The area can be obtained by using double integration. And for that, we use the formula double integral over the region dA will give us the area of A. Here the function is considered as 1. F of xy is considered as 1. Now we discuss the example on finding the area by using multiple integral. So here the example is to find the area bounded by two parabolas, bounded by two curves y equal to 4x by 5 and the axis x-axis and the ordinates at x equal to 5. Here we consider the region. We draw the figure. Y equal to 4x by 5 is the straight line passing through the origin. The x-axis and the ordinate at x equal to 5, which is the line parallel to y-axis passing through x equal to 5. So the area over the region is obtained by using double integral. For that we consider a vertical strip here, and from that we find the limits. Here in the bounded region we have the values of x as x varying from 0 to x equal to 5, and limits of y can be obtained from the ends of the strip PQ. So at the lower end of the strip, y is equal to 0, and at the upper end of the strip, y is equal to 4x by 5. So these are the limits of y. So now we write the area as double integral x varying from 0 to 5, y varying from 0 to 4x by 5 dy dx. We solve the inner integral first and we obtain its result as 4x by 5. And then we solve the second integral x varying from 0 to 5, 4x by 5 dx, and we obtain the result as 10 units square. So this is the area which is obtained by using double integral. In the next example, we find the area enclosed by the curves y square equal to 9x and y equal to x square by 9. These are two parabolas. We get the required region as shown in the figure. So for finding this area, we have to consider a strip. We can consider a vertical strip or a horizontal strip. So here in this case, we are considering here the vertical strip. Now for deciding the limits of y, here the lower end of the vertical strip is on the curve y equal to x square by 9. Hence the lower limit of y is x square by 9. The upper part of the strip is on the curve y square equal to 9x. Hence the upper limit of y is y equal to 3x raised to power half. Therefore the area bounded by this region is given by the double integral extending from 0 to 9 and y varying from x square by 9 to 3x raised to power half dy dx. We solve the inner integral first and get its answer as 3x raised to power half minus x square by 9, and then we solve the next integral. After solving this integral, we get the final answer as 27 units square. Here is the problem for practice. Thank you.